Hey, check it out. There's three alternators sitting here, all the same size. But check out what he says, what the power of these are.
Here. Today I want to conduct a little experiment. I got three alternators here, a 250, a 160, and a 136 amp alternator. All meant for the 4.7 liter and 3.7 liter Chrysler Jeep Dodge engines.
Anyways, cutting him short. That 161 is really where I want to be at with the e-bike motors. That seems to be really, really good. Don't want to go like 250, that's too much amperage. So really, when you start working these out on paper, I'm running an electric cockroach bike, a 12 volt at 110 amps. You times that 12 by 110 amps and it equals 1320 watts. Okay, so that's what the wattage really is of the 110 alternator that I'm running. And this is how you can find out the what the watts of an alternator is. See, with e-bike motors, it just tells you straight out what the wattage is and the voltage and how much amps. It just tells you. But on an alternator, sometimes it just doesn't tell you that. Okay, on a 160 amp alternator at 12 volts, it works out to 1920, so close to 2000 watts. Okay, and then we come down to the carcass motor, which is an alternator at 12 volts and 55 amps. And so that is only really 660 watts. And that there is actually why it's only half the speed of the cockroach, even though it was powered up on 48 volts. Now here is the so-called 2000 watt motor that you get for an e-bike, that or an e-scooter rather, that's at 48 volts. So 48 times 40 amps, because there were 40 amp motors, see, and it equals 1920. So our 1920 falls under this category here with the 160 at 12 amp alternator at 12 volts, see? So it's the same. So that's why this is the best conversion. See, in the alternator range, that would equal the 2000 watt e-scooter motor. See, the other thing is the actual controllers that I'm using are 1000 watts, but because the ohmage is dropped, you're basically getting twice the power out of it anyways. So the ohmage is changed in these alternators. It's lower than the e-bike motors, which means you're getting twice the amount of wattage out of your controller. So, in fact, a 1000 watt controller actually becomes 2000 watts in power. So that's how you're winning with that. Okay, so yeah, there's all kinds of alternators, double delta, but I've just found the actual middle ground for running a 1000 watt brushless controller on a 160 amp 12 volt alternator. You convert it, of course. Yeah, so you take out all the bridge rectifier, all that relay, and you got the three wires poking up straight out of the outside field wires out of here, which just goes back to your controller, the brushless controller, and the brushes here, which is two brushes, and two wires coming out. One's positive, one's negative. That just goes back straight to a 12 volt battery, and then the center magnetic field can emanate out to the outside field, which the center's DC 12 volts. The outside here is alternating current, and that's actually what makes it turn direction, because if you swap two of these wires out around the other way, the motor starts spinning the other way. But if you swap these wires around on the battery, it does nothing. All it does is just swap the poles from one side of the motor to the other, but the direction still remains the same. So yeah, guys, little tips on alternators, and so yeah, pretty cool. So this is about a 1300 watt one. So that's interesting to know. That's a Ford alternator 110. So yeah, I might as well actually make this a bit of a vid. So this is the other one at 55 amps. This is on the electric carcass bike here, and so yeah, uh, 55 amps at 12 volts equals 660. So that's a 660 watts of power going to that back wheel there. So, but it's only half the speed on 48 volts 1000 watt controller as this bike. See, that's 110 alternator, so twice the speed. So cool, guys. How much volts have I got left on there? Oh yeah, it's still 51.4. Yeah, pretty cool, eh? Cool, cool. See you in the next vid.